planets and dwarf planets. What led to this whole debate was when we started discovering objects that didn't quite fit and made us start to reevaluate what we were calling a planet. And the first of these to be discovered was Quawar. This was discovered in June of 2002. And here we see an artist's impression of Quawar and showing the relative size with Earth and our moon and Pluto here. Well, relative to Pluto, as you see here is the size, it's about half the size of Pluto. Now, figuring out sizes of these things is done by a lot of guesswork because we can't actually see a disk. So we look at things like the brightness, and then we have to guess about the composition and how reflective it is. And so based on that, plus the known distance, is how we get an estimate for the size. So there's two things in our list here that we are guessing about. And so that's why we say approximately, because we really just don't know. Quawar, as far as distance from the Sun, is 42 astronomical units from the Sun. Remember that 1 astronomical unit is Earth's distance from the Sun. Pluto is 40 astronomical units. So Quawar is not that much farther from the Sun than Pluto. So kind of in the neighborhood as far as positions are concerned. The next one to be discovered was Sedna. Again, we've got our artist's impression of what Sedna looks like, and this was in 2004. And here we see Sedna is about 3/4 the size of Pluto. Again, using all those guessed criteria. So getting even closer to Pluto's size, but a lot farther away. Sedna is 90 astronomical units from the Sun. So that's more than twice Pluto's distance from the Sun. So that's getting way out there. Eris was discovered in 2003, and here we see it relative to various other objects, including Sedna and Pluto. And Eris is really the one that set things off because it is bigger than Pluto. And because this caused all sorts of confusion, the name Eris is named for the god of confusion and strife and turmoil. So this object caused confusion and strife and turmoil. Distance, 120 astronomical units. So 3 times as far from the Sun as Pluto. So we don't quite know what to make of that. That would actually put it out in the Oort cloud at those kinds of distances. And then we kept finding things. Haumea was discovered, 2004. Again, artist's impression. It's about half the size of Pluto. This one we do think is elongated. It has 2 moons, which you can see pictured here. And based on the light of the moons blocking the light from Haumea, we can get an estimate of its shape and size. And here we're back at 42 astronomical units. So we've got Pluto and Quawar and Haumea all in the same neighborhood. 2005, we found Maki Maki. Here's Maki Maki, and see all our others here, Qualwar, Sedna, Eris, Haumea. About 2/3 the size of Pluto. And it's at 45 astronomical units. So again, more or less in that same neighborhood. So all of this led to the International Astronomical Union. To ask the question, what is a planet? To try to come up with an official definition. It seems odd that, it wasn't until 2006 that astronomers felt the need to define what a planet is. But all these objects started to defy our common sense. And so the IAU got together in 2006 to hash out what should be the best definition. So one possibility was, okay, since 1930, we have had 9 planets, so let's just keep it at that. So, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, which are shown here. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and Pluto is there. Those would be our planets, and just keep it as is. Well, some said, well, what about Eris? Because Eris is bigger than Pluto. Should we consider that a planet? So some said, okay, let's do historical plus. So if we find anything bigger than Pluto, we'll include that. So that's going to add Eris to our list of planets. Some said, well, I'm not real thrilled with that idea. What about looking at some kind of physical characteristic that would give us a boundary of something large versus something small? And if it's big, it's going to make itself round. The more mass you've got, the more it's going to pull itself together and get a nice round shape. Well, if we include that, then one of our asteroids is gravitationally round, the asteroid Ceres. And we've got Sedna, Eris, Haumea, Maki Maki, and possibly even including Pluto's moon Charon, because Charon is so close in size to Pluto that we might call it a double planet. So this would have really opened up how many planets we had in our solar system. And then they said, okay, let's keep this thing that has to be round. But, Ceres is in the asteroid belt. And so it's orbiting with all these other objects. We really shouldn't consider that a planet. Pluto and the others, sorry about that, my cat just wanted to jump up and join the conversation. These are all in the Kuiper belt. So they're sharing their orbit. So what if we instead eliminate anything that's sharing an orbit? We're going to say the orbit must be clear. Well, ultimately, this is the definition that was chosen. So what is our official definition of a planet? Well, the first criteria is, of course, it has to orbit the sun. Originally, this was the definition. When, as long as we had a heliocentric model, this has been our definition of a planet. It just needed to orbit the sun, which is why when the first asteroids were discovered, they were called planets. Because they orbited the sun. And that was all we needed. And it wasn't until a lot of asteroids were discovered that we decided, okay, no, we can't call all of these things planets. And that's kind of what's happening with Pluto and these other dwarf planets. But we still do need it orbiting the sun. So that's criterion number 1. We want it to be gravitationally round. So that means that gravity needs to pull in enough that it actually squeezes it into a round shape. Small asteroids have the kind of potato look to them, so small objects aren't round. They have strange shapes. So, majority of asteroids would get kicked out because of this criterion. A lot of the Kuiper Belt objects would. Most of the comets would. So those would not be considered planets. And then it was the cleared orbit thing. So, our asteroid belt here, lots and lots of asteroids orbiting around the sun. So anything in the asteroid belt, not going to be included. And then you've got the Kuiper Belt out here where Pluto is. Again, lots and lots of objects, thousands of objects in the Kuiper Belt. So if it's in the Kuiper Belt, or if it's in the asteroid belt, it is sharing its orbit because it's got other objects in essentially the same distance orbiting. And so anything in those two places, not planets. So that upset people about poor Pluto. Okay, it's not a planet. So a new definition, a new category was developed for a dwarf planet. So the criteria for a dwarf planet still has to orbit the sun. So, asteroids and comets, those orbit the sun. So that works for them. Still needs to be gravitationally round. So essentially that means it needs to be fairly large. So here we see an image of all sorts of objects that meet that criteria. We've got Pluto, Haumea. It's elongated, but it's still pulled into a fairly round shape. Eris, Sedna, Makemake, Quaoar, Orcus, Ixion, Varuna, and one that didn't have a name when this graphic was made. All of those are big enough to be round. And what distinguishes them from planets is they share their orbit. So basically, if it's in the asteroid belt, or the Kuiper Belt, and it's round, then we're going to call it a dwarf planet. And this graphic is really dark, but you're seeing the orbits of a bunch of different dwarf planets. So Makemake, Ixion, Varuna, Haumea's in here, Orcus, Eris. Here's Pluto's orbit. Here's Quaoar's orbit. You can see these things really do overlap. They're all in the same region, and their orbits are very much combined. So Pluto definitely fits in better with these guys than it does with our planets, and so it makes sense for Pluto and these other objects to have their own criteria and their own category.